Welcome to the first video of many in the series of physics tutorials. In physics, we consider both the size or magnitude of values and their direction. Scalar quantities have magnitude only, such as 5 milliliters of water or 8 joules of energy. Vector quantities have both magnitude and direction. These quantities tell us not only how much something is, but also where it is going. For example, 5 meters per second north, or 9.81 meters per second squared down. When describing the physical location of an object, we can use three terms. Firstly, distance. This is a scalar quantity and is a measure of the separation between two objects, or between an object and a 0 point. Secondly, we can also describe the position of an object. Unlike distance, position is a vector quantity. Position is a measure of distance, which is the separation between two objects where an object and a 0 point combined with the direction of the object relative to a point that is oftentimes a 0 point. Finally, there is displacement, which is going to be the concept you see most often out of the three in kinematics. Displacement is also a vector quantity and describes the change in position. The sign of the number can be used to replace direction. Displacement equals change in position, which then equals final position minus the initial position. As an example, if the final position was 10 meters left and the initial position was 1 meter right, where positive values are towards the right and negative are towards the left, we would first need to convert these values into the same direction. We change them to either right or left, but I chose to do left to demonstrate how negatives and direction changes work. Thus, the final position would be 1 meter right multiplied by -1, which equals -1 meter left. Then we subtract the final by the initial position, giving us 11 meters left, or -11 meters. In this case, the negative sign and the left direction have the same meaning since we had initially assumed that right was positive. Here's a quick sample problem for you to try. If the reference point for the cars is at 0 on the grid measured in kilometers from left to right, then what is the distance of point A to point B? Well, distance is a scalar quantity, so 5 minus -2 would be 7 kilometers without a direction. Now, what is the distance of point B to point A? Similarly, the distance would also be 7 kilometers without a direction because we are just taking the largest value and subtracting it by the smaller one, giving us the same value regardless of which point we are calculating from. As shown in the diagram, the positions of point A and point B relative to the center 0 point are 2 kilometers left, or -2 kilometers and 5 kilometers right, or positive 5 kilometers. What is the displacement of point A from point B? Since displacement is final position minus initial position, we would subtract point B by point A, which is just 2 kilometers left minus 5 kilometers right. When we convert 5 kilometers right to -5 kilometers left, we get 7 kilometers left, or -7 kilometers. What is the displacement of point B from point A? Following the same calculations as the previous question, 5 kilometers right minus -2 kilometers right gives us 7 kilometers right, or just positive 7 kilometers. One important thing to note is that any vector quantity with a value of 0 does not need a direction, such as 0 kilometers. Here's another problem to test your understanding, but with a two-dimensional graph instead of one. Calculating the position of the jogger at the time intervals of 10 seconds, 40 seconds, and 100 seconds. Referring to the position time graph on the right, we can simply observe that at 10 seconds the position is 0 meters, no direction, and at 40 seconds, we get 10 meters east, or positive 10 meters. Finally, at 100 seconds, we see that the position of the jogger is at 30 meters west, or -30 meters. Next, we are asked to calculate the displacement of the jogger during the time intervals 20 seconds to 70 seconds. Subtracting the final position by the initial, we get 20 meters east minus 10 meters west, which would equal 20 meters east plus 10 meters east, giving us a final answer of 30 meters east. One important thing to point out is that you should always change the direction so that your final answer is a positive number. For example, we would convert -30 meters west to positive 30 meters east in the final answer. The jogger's final displacement after 100 seconds would again be final position minus initial position, which is 30 meters west minus 20 meters east, and converting east to west, we get 30 meters west minus negative 20 meters west, obtaining the final answer of 50 meters west. The total distance traveled by the jogger is the sum of all changes in positions. Since this distance is scalar, we are only measuring the magnitude, so there are no negatives. Thus, the total distance is the sum of the absolute value of all changes in positions. In other words, we are finding the differences in the jogger's position at the peaks and troughs of the graph and adding them all up. Adding up the changes in positions, we obtain the following sum, giving us 170 meters as our final answer. Velocity is a measure of the rate of change of displacement, meaning it is a vector quantity. Velocity is usually denoted by v, but when specified, initial velocity is denoted by u, and final velocity is denoted by v. V equals s over t is a formula for the average velocity within a specific time interval, where s, displacement, is usually measured in meters, and time is usually measured in seconds. However, kilometers per hour is also quite common, and it is important to know how to convert between these two units. The following formula is an expansion of the v equals s over t formula from above. It is important to note that speed is not the same as velocity. Speed is scalar while velocity is a vector, meaning that speed does not have a direction while velocity does. Since v equals s over t, we can find the instantaneous velocity at a certain point along a position time graph or displacement time graph, which are the same thing. The first step is to draw a tangent line parallel to the curve at the point. Next, we calculate the slope of the line by using rise over run equals change in displacement over change in time. For example, drawing a line tangent to point P, we get 26 meters divided by 5 seconds, giving us 5.2 meters per second forward. When we are not giving a direction, we can assume that backwards is negative and forward is positive. Keep in mind that the slope calculation only gives an approximation of the velocity. Depending on how you drew the slope, the velocity could vary. Average velocity is the total displacement of an object divided by the total time. For example, average velocity equals total change in displacement over total change in time, which gives us 3.2 meters per second forward. When an object is moving uniformly, or in other words, when the slope of its displacement time graph is constant, its instantaneous velocity is equal to its average velocity. Here's a practice problem that is slightly more challenging, so try to follow along. Feel free to pause the video and reread the steps at any time if you're confused. The question is as followed. During a field trip to the amusement park, the school bus traveled the 60-kilometer distance to playland while maintaining an average speed of 90 kilometers per hour. Calculate the average speed the driver must maintain on the return trip if you wanted to have an average speed of 70 kilometers per hour for the entire trip, both there and back. Firstly, state what you know. We know that the distance there equals the distance that it takes to come back, which all equals 60 kilometers. And the velocity there is 90 kilometers per hour. From this information, we can derive the equation 60 kilometers divided by 90 kilometers per hour equals 2 over 3 hours. Secondly, we use the fact that the average velocity equals the distance there plus the return distance divided by the time it takes to get there plus the return time. From this, we can derive the equation 70 kilometers per hour equals brackets 60 kilometers plus 60 kilometers close brackets, all divided by 2 over 3 hours plus the return time. Then, we multiply both sides by the denominator 2 over 3 hours plus the return time. You should end up with the equation of return time equals 120 kilometers minus 140 divided by 3 kilometers, all divided by 70 kilometers per hour. Finally, we can derive the final equation based on the formula return velocity equals return distance over return time. Now, you should end up with an answer of 57.27 kilometers per hour, or 57.3 if you're rounding with 3 significant figures. Note that no direction is included in the answer because speed is a scalar quantity. Acceleration is a measure of the rate of change of velocity and is vector quantity. Denoted by a, where a equals change in v over change in t, is usually measured in meters per second squared. Meters per second squared just means meters per second per second. This is the rate of change of displacement every second. Try to wrap your head around this. For example, if a car was traveling at 3 meters per second at the time interval of 0 seconds and accelerated to 4 meters per second at the time interval of 1 second, the car has increased its velocity by 1 meters per second every second, and thus its acceleration is 1 meter per second, which in simple terms is just 1 meter per second squared. Similar to instantaneous velocity, you can calculate instantaneous acceleration by calculating the slope of a line tangent to a point, but on a velocity time graph. Average acceleration is the total velocity gained or lost divided by total time. When velocity is uniform, both average acceleration and instantaneous acceleration are constant and equivalent. Now let's go through a quick practice question. If the acceleration of a free-falling object on Earth's surface is 9.81 meters per second squared, and air resistance is negligible, determine the velocity of an object after it has been free-falling for 4 seconds if it was initially thrown down at 3 meters per second. Firstly, we assume that down is positive. Then, by plugging in the values and rearranging the equation, we get the answer of 42.24 meters per second down. There is actually a formula that makes this calculation easier, but for the sake of testing your understanding on how acceleration works, we will introduce that later on in the next video. That's all for the video today. Thank you for watching. See you in the next video.